Hi, this is Mr. Von Neumann. In this tutorial, I'm going to show you how to take the Exoplanet app, take a planet from that app, another exoplanet in another solar system, and look at the data and analyze it to figure out what the temperature is on that planet and if you can live on it or land a spaceship on it. The steps, if you're doing my assignment, are listed out in the assignment, and the first step in the analysis will be the size and temperature of the exoplanet star and figuring out if it's bigger, smaller, hotter, or colder. The planet we're going to analyze is GJ9698b. It's a super Earth. A super Earth is a rocky planet just like Earth, but larger in size. And it is 0.59 solar masses. The size of GJ's star, which would be its sun, is 0.59 solar masses. Well, if you don't know what a solar mass is, it is our sun. We use our sun to come up with the unit solar mass. So one solar mass is our sun. It's what all other stars are being compared to. So is GJ's bigger or smaller? The number is less than 1, so it is smaller than ours. The formula that we're going to use in order to come up with our calculations is difference between the two stars divided by our sun. So in this case, the difference will be 1 minus 0.59, which will be 0.41. And you're going to divide it by our sun, which is 1. Anything divided by 1 is just going to be itself, so it'll just be 0.41. When we do the temperature, same formula, but very different. It's not going to be 1 at the bottom. So 0.41, we're trying to get this into a percent. So to take that into a percent, all you have to do is multiply it by 100 or move the decimal over twice, and you get 41%. So that'll be the first thing you'll write about in your analysis. We would say that GJ's star is smaller than our sun by 0.41 solar masses, which is 41% smaller. Now on to the temperature. The temperature of GJ's is 3,836. Our temperature of our sun is 5,778 Kelvin. It's a weird unit, but basically if you roughly multiply it by 2, it'd take you to Fahrenheit, so the temperature of ours is about 9,000. But Kelvin is the unit that we're using. So 5,778. Ours is, or GJ's is 3,836. Go to a calculator, take the difference, and you're going to wind up with 1942 is the difference. 1942 divided by our sun's temperature, which would be 5,778. If you go ahead and take that to the calculator and you divide those two, you get 0.33. So 0.33, if you move the decimal over 2 spots, you wind up with 33%. Also, always check yourself with common sense. If you round that to 2,000, round that to 6,000, 2,000 over 6,000 would reduce to 2 over 6. That would reduce to 1 over 3, which is about 33%. So you would ultimately say that GJ's star is colder than our sun by 1942 degrees Kelvin, which is 33% colder. And that's the end of step 1. Now we can use those percentages to move into step 2 and figure out where we need to place our planet away from its star to be like Earth.